All right, so I got posed a question the other day, which was, why do some stores target dew point, and why do some places target relative humidity? And, what are they and everything? So first off, we're just going to describe relative humidity. So relative humidity is how humid it is relative to how possibly humid it could be. So for instance, let's say at, 75 degrees, it's 55% relative humidity. That means that the air at 75 degrees is capable of holding, well, I actually have an example down here where 86 degrees Fahrenheit is capable of holding 0.0052 pounds of water per foot, right? And you can imagine that kind of like, distended in midair, like water vapor particles, right? Like this is a box filled with air, right? So we got those distended particles, right? So what happens is, so at 55% humidity, maybe we'll just use 50 just for easier. But so, for example, we would just divide that by 2, which would get us 0.0026. That would be 50% humidity for 75 degrees, which means that there's only half as much water vapor particles floating in that air that could be, okay? And that's just a property of air. So if we go over to this table that I loosely drawn, max water content and temperature, you can see that as temperature increases, your max water content increases in your air. So your air can hold more water when it's warmer, right? So if you're in a store and you're targeting relative humidity, what happens is, your system will look at it and say, well, given the temperature of the air, and then I'll have a humidistat, and we'll go, it's there's this many particles of moisture in the air, whatever it happens to be, okay? The moisture volume concentration. It'll say, oh, okay, we got 50% humidity at 75 degrees. Okay, that's about where we want. Now, dew point. Why would you target dew point? It's a little different. What is dew point? So dew point says, what humidity, what temperature would this have to be in order for it to be 100% relative humidity? That means that at 75 degrees, if we were to cool this air down in this box, what temperature would we reach 100% relative humidity? And that's dew point, which is 57.7 degrees Fahrenheit. I just put it into a calculator. This isn't a video on how to calculate these things. It's just a video on kind of roughly what they are, right? So at this point, it means that this air can't hold any more moisture. So like if you, let's say, boil a pot of water or something, it's just gonna condense instantly. This air can't hold any more. There's no more moisture that air can hold, period. Okay? But the thing is, the moisture in these two cases is the same. The entire moisture content is the same. Because, for instance, let's say, this is the box at 75 degrees, relative humidity, and this is another box at 57 degrees, 100% relative humidity. Well, this is capable of holding less humidity than here. So even though this is 50% and this is 100%, the moisture is the same. It's the same amount of water in both cases. So over here you see little line of water, little line of water. It's the same in both cases. It has equivalent moisture as total overall moisture. Okay? So, why is this significant? Well, if you're looking at a store, right, the reason why you would want to maybe target dew point is you're concerned with overall moisture in your store. Okay, you're concerned with this, like, 16,092 parts per million. Okay, that's the moisture content. And maybe your engineer came up with, it can only be 1,500, or 15,000 parts per million or something, right? So you want to target, like, let's say this box is your store. You want to go, I want my store to have only, 16,000 parts per million moisture everywhere. And you're capable of achieving that at varying temperatures because of dew point. Why? Because if we go back over here, your air will hold less moisture the colder it is. So if you look at these two examples down here, this is 89 degrees Fahrenheit, and this is 59 degrees Fahrenheit, right? So one of them is capable of holding 0.0052 pounds per feet squared, and the other one is capable of holding 0.008 pounds per feet squared. Okay, now if we do this out, it works out like this. So even though it's not increasing 6 times the temperature, 86 degrees Fahrenheit can hold 10 times the amount of moisture per foot as 59 degrees, right? So if you were to target dew point, you're targeting the total moisture in your system. Because let's say if we do 50% relative humidity of 86, if you look at this, 50% is still 1, 2, 3. This one over here is 1.5. Okay? So even at 50% relative humidity at 86 degrees, it still has more total moisture than 100% at 59 degrees. You see? So the reason why people would target dew point is because they're concerned with the whole amount of humidity in your store rather than relative to itself. Like, who cares how much humidity your air can hold? I care about how much humidity is actually in the store. Now, why does this, from what I've seen, not work? It's because people put it in at this value right there. So 75, 55. So your refrigeration equipment is made to run at 75 degrees, 55 relative humidity. That's the max operating condition. And some fella somewhere gets this idea and goes, well, I'm going to set all my stores for the max operating condition. So they set all their stores for this dew point down here, and it doesn't work. And they go, oh, I don't know why. It's because you need to set it lower. You need to set it for closer to, at least in my opinion, which runs decently smooth. If you want to save money, like 70 degrees at 40% relative humidity. Okay, and then you would find the corresponding dew point to that. Look at the corresponding dew point is 47.7 degrees Fahrenheit. So that's what I would target. If this is what you're hoping to achieve, I would target this dew point. So that means if, let's say, your store is 65 degrees, it's wintertime or something, it could be like 80% humidity. But because 65 degrees can't hold as much humidity as 70 degrees, your moisture content will work out so it's roughly the same or less. So that's why in HVAC you would target dew point over relative humidity. I hope you found that helpful. I hope somewhat of a decent explanation of why you would target one over the other. A lot of guys I know, they will live and die by relative humidity, which is fine. My philosophy is, if it makes your store work, go for it. Some stores are more finicky than others. Maybe it's your sensors placement, sensor locations. You know, a lot of times I find that they're not really preferable. You know, sampling locations for your sensors, could be all kinds of things. But anyway, if you know something more, you want to add something to the conversation or edit what I say, remember, I'm just a dude on the internet. Double check everything I say. Comment in below. I want to learn from you guys. I've learned so much. I feel like a lot of people are learning. It's a good place to grow and develop. Well, I'm hoping to make this channel a place where you can learn, develop, grow, become all around better tradesmen. Anyway, like, subscribe. Thank you. And that's how you do it.